Hello. Perhaps you are wondering why I'm starting with the picture of a scooter. Well, let me elaborate. What you see here is the high school I attended when I was about 16. And you know, becoming 16 is an exciting age because with 16 we have been allowed to drive a moped or a scooter. And somehow I remember it back then, we were discussing a lot in our class. What's better, a moped or a scooter? Somehow there were some moped people and there were some scooter people. And for some reason, they were not the best friends with each other. When I'm looking back to this discussion, which one is best, then I need to say, well, this discussion was somehow ridiculous, wasn't it? Because you cannot tell in general what's better. And in this very case, there is not a big advantage anyway. Perhaps the biggest advantage here is belonging to this or to that group. And this reminds me to doing decisions, because when doing a decision, it is all about consequences in your very situation. You have to evaluate options in your very situation, and you have to say, well, this option provides now more advantages than disadvantages. This is in general true for doing decisions, and it's also true, hence, for doing software architectures, because software architectures are all about decisions, aren't they? And one software architecture that comes with a lot of decisions, having a lot of options with advantages and disadvantages, is Micro Frontends. This is where everything leads to the topic of today. When you go with Micro Frontends, you have several tiny frontends, and those frontends are implemented in isolation. And then somehow you need to integrate those frontends into a bigger wall, into, let's call it, a shell. And yeah, this is what this talk is about. I want to tell you why it's necessary sometimes to go with Micro Frontends. For this, I'm showing you some real-world case studies. I've interviewed several customers of mine. And those case studies also show where are the advantages and the disadvantages in their very case. And it shows when it can be okay-ish and a good idea to go with this approach, and when it would be better to don't go with this approach, to go with another one. This is the first part. In the second part, I want to show you how to implement Micro Frontends. There are several options. I will show you a very modern option, namely module federation. It's quite modern. It's here since last fall, and it's really straightforward. But before we get started, let me introduce myself. I am Manfred. I'm a trainer and consultant for Angular. I'm doing a lot of in-house trainings and consultancy for Angular in the area of enterprise development. Normally, I'm doing this on-site. In times like this, I'm doing this remotely, and it really works nice. Besides this, I'm quite connected to the Angular community, and perhaps you hear it at my accent. I come from Austria, and I do a lot of stuff in Germany, and sometimes I'm also allowed to enter other countries around the world. I'm always happy if I can work together with people around the world nowadays, as mentioned, in a remote fashion. Okay, let's get started with the first chapter I've prepared. This is about why. Why shall we use Micro Frontends, and why did my customers decide for them? One case study I want to start with is Daedalus Healthcare. It was formerly known as Agfa Healthcare, and they are doing hospital information systems. You can imagine when it comes to a hospital, there is a huge amount of data to be managed and a huge amount of processes and use cases. And what they did is they subdivided all their data structures and use cases into tinier, separately implemented micro frontends. They have been implemented by different teams, and then they are combined to a bigger wall, to a bigger application. Another case study is DATEV. DATEV is, as you see here, quite a huge company in Europe, and they are focusing on software for accountants and lawyers. And their main product, or one of their main products, is a product for managing payroll accounting. It aligns with all the laws in different countries. It's quite huge. And they expect that they will have about 80 developers in the final stage of this software. Because the current version has about 80 developers, now they are starting again. They are rewriting it with modern technologies like Angular in the front end. And they also expect they will end up with about 60 to 80 developers here. And because of this, they also decided to split everything into tiny parts and to make it possible that each and every part is developed by a team of its own. And of course, at the end of the day, everything needs to be integrated into a shell, into a common whole. Another case study is from a huge European bank I'm consulting for several years. What they are doing is they are creating a new e-banking system. And you know, for us, e-banking is very cute. There is a dial, and here is a dial, and all my data is displayed. But at the end of the day, all those dials come from different business domains. Some of them come from account management, some of them come from stock management, some of them come from loan management, and so on. And of course, different business domains call for different business experts, and that's why they have different teams for the domains. And at the end of the day, one more time, they need to integrate those domains for us. Another case study is from another huge European bank. They do the same, but they do it with customer data. Data about their customers. This data is used if a customer reports an issue. Then they use all this data from different domains to hunt down this very issue. And finally, there is another case study from a company called Quality Bytes. And this is quite funny here, because Quality Bytes is a small business. It's run by a friend of mine. They are, let's say, one agile team, 7 plus minus developers. And they told me, hey, for us, Micro Frontends is too much because we only have one team. For us, it does not make sense to split our application. By the way, it's also a hospital information system to split our application into tiny parts. That would be too exhausting. But what they do, and I really find this smart, is they are subdividing their one application internally into business domains. All the business domains are part of one monorepo, part of one big application, but internally the code is separated. And this makes sure that one business domain cannot be intermingled, cannot be coupled with or to another business domain. This allows to evolve the software a bit easier because nothing is intermingled, and so changing something here does not break something there. They are doing this with NX, which is quite a nice solution for huge enterprise scale Angular, but also React application. It even supports more frameworks, and it allows to define linting rules, preventing that everything is accessing everything else. So they decided against it, but still they go with domain slicing. Okay, so as mentioned, I interviewed those companies, and one question I asked them was, what have been the reasons for adopting Micro Frontends? And as mentioned before, the main reason is that they have a huge product or even a product suite, and they want to split it. Split it into tiny parts that can be developed and deployed in separation in an autarkic way by individual teams. So first and foremost for them, it's about scaling teams, isn't it? Scaling teams across domains. So another reason is switching out technologies. This does not make sense in short term, because in short term, you don't want to have a framework zoo. In short term, you want to stick with one framework, perhaps Angular or React or Vue. But in mid or long term, this can be beneficial, because this allows you to migrate little by little, domain by domain, micro frontend by micro frontend to a newer technology. And this is really important, because when we talk about enterprise scale applications, we talk about applications that need to be maintained for several decades. And you know, sometimes technologies appear and disappear. That means having the possibility to switch out technologies is not that bad. If you think back what you did 10 years ago, I guess it was a quite different technology stack. Another thing I heard from some customers was they have repeatedly changing requirements. If you think about software that is highly regulated by law, like software regarding healthcare or even payroll accounting, then you need to adjust it on a regular basis to the current law. And you don't have a lot of time for it. You have to adopt it until the law is in place, perhaps until the end of the year. And having a lot of tiny slices that are independent from each other also can help here, they told me. So this was about the reasons. But one big question is, what have been the consequences? What have been the drawbacks of applying this architectural style? And honestly, as mentioned in the introduction, using mopeds and scooters, there are a lot of consequences and a lot of drawbacks. One consequence is that a lot of teams had a lot of effort by or with creating a meta framework. A meta framework is an orchestration layer that loads this micro frontend, that micro frontend, and displays this or that one. Somehow you need to display them, somehow you need to hide them, somehow you need to route between them. Also, communication is a topic, communication between micro frontends. Another drawback was that there seems to be a trade-off situation between sharing code and huge bundles. If you share your code, let's say if you share Angular itself amongst all your 10 micro frontends, the micro frontends come with smaller bundles because they don't need to bring their own Angular. But on the other side, they are dependent upon the shared version. That means if I update the version of Angular, this will immediately influence all the micro frontend using this very shared version. So somehow this is a trade-off situation. If I don't want to share code, then each and every bundle comes with its own Angular version, but this increases the bundle size. That means you have one of those two drawbacks. You cannot have both of them. As the Americans say, you cannot have the cake and eat it. You have to decide for one option: sharing code or bigger bundles. Yeah, and another negative consequence they told me was it is difficult to apply a common look and feel because all the micro frontends are built in isolation, and somehow you need to make sure that they have a common look and feel when integrating everything into your shell, into your common whole. Sometimes that's more important, sometimes that's less important. I would say the third thing is more something that has to do with design systems. This talk is not about design systems. At this conference, we have a lot of other talks about this very topic. Hence, I will concentrate on the more technical aspects here, namely creating a meter framework and sharing code versus bundle sizes. Okay, this was the first part. And as promised, I've shown you why my customers decided for micro frontends and what consequences they had to deal with. Now let's come to the second part. In the second part, I want to show you how to implement micro frontends. And of course, there is a huge amount of options for micro frontends. Some people used iframes several years ago. For some reason, iframes are not the most famous HTML tag. It's about as famous as the Blink tag, if you ask me. Some people used hyperlinks, other people used web components. Here I'm using the new kid on the block, namely Module Federation. And if you ask me, Module Federation is so far the most straightforward way, the most unobtrusive way of creating micro frontends. I guarantee you, you will love it. Well, what is Module Federation about? Well, at the end of the day, Module Federation allows you to do something like this here. It allows you to load something from a different application, an application that has been deployed in isolation, that has been also built and developed in isolation. And perhaps you are saying now, yeah, come on, Manfred, that cannot be that difficult. Because we have this await statement since ECMAScript 2017, and even before we had counterparts like require, for instance. So why is this new? Well, the thing is, in theory, you can just use import and you are fine. In theory. In practice, just using import is not enough. And that is because of how all the bundlers work. All the modern bundlers, like first and foremost Webpack, which is used by all the frameworks out there, also by the Angular CLI. Those bundlers try to squeeze everything out of our bundles. They aim for creating tiny bundles. And that's why everything is compiled together. Everything needs to be known at compile time, even the lazy parts. Everything is compiled together. Everything is optimized together. Think on tree shaking, for instance. And then, and only then, everything is cut into chunks. But for our purpose, this is too late. Because when we go with micro frontends, we don't know all the micro frontends upfront. We only know them at runtime, because at runtime, we are loading this or that very micro frontend in this or that very version. Yeah, and this is something Webpack 5 Module Federation is solving for us. For this, Webpack 5 Module Federation, which is, by the way, an integrated feature of Webpack, it's not an add-on, it's an integrated feature, defines two roles. One role is the host. In our case, this is the micro frontend shell. The other role is the remote. In our case, it's the micro frontend itself. You can configure both of them. You can say, hey, my shell has a mapped URL, the mapped URL MFE1, and MFE1 points over there to a different application, to a micro frontend. Separately deployed, separately compiled. And by the way, over there, it's also called MFE1. This allows you to define an alias, or to say the least, a non-alias in this very case. This is the first thing you need to do. You need to map URLs pointing over there. And over there, you can expose files. You can say, hey, I have this very file here, and this file is exposed under the name CMB. This file, for instance, holds a component or a module with roots. It could also hold a function or just an object. It can be literally everything. It's exposed under a given name for the shell. And now something beautiful happens. I guarantee you, you will love it. Now you can use a dynamic import using the map names pointing over there. And so this allows the shell to load the exposed component, the exposed module, the exposed function. The best of this is that Angular itself, Angular or your framework of choice, does not recognize at all that you are going with micro frontends. For Angular itself, this is just about lazy loading. That means you use your framework as it is intended to be used. You use your framework as always. You don't need any extra logic, any orchestration framework that is orchestrating different applications in your browser window for you. And this is awesome because this is where the cycle closes. If you think back what I told you that a lot of my customers claimed that creating an orchestration layer, a meter framework, was quite difficult and exhausting. Now we don't need to do this anymore. Just do a dynamic import, just use lazy loading from your framework, and you are fine. Of course, we need some metadata about the micro frontend to load it into the shell. This metadata is emitted by Webpack. Webpack writes it into a so-called remote entry point. It's just a JavaScript file. This JavaScript file has about 2 or 3 Ks in production, and you need to load it into your shell. By loading it into your shell, the shell knows where to find the micro frontend and how to interact with it. It knows where to find which bundle of it and which bundles need to be loaded for specific use cases. The metadata also tells the shell which dependencies the micro frontend needs. If it needs Angular, if it needs React, if it needs react.js. And by knowing that, the shell can share existing library code with the remote itself. And sharing code is really as easy as that. Just mention the libraries on both sides you want to share, on both sides, like Angular Core and Angular Core here. And this means that Angular Core is not loaded twice if you go with 2 micro frontends. It is not loaded 10 times if you go with 10 micro frontends. No, it's only loaded once and shared across all your frameworks. Or across all your micro frontends, to say the least. And of course, when sharing code, there can be version conflicts. Perhaps this application is using Angular 11, that one is using Angular 12. Those conflicts need to be resolved somehow. But this is also something module federation is capable of. If you're interested into details about resolving conflicts, have a look into my blog. I have listed some details there. But for now, it's enough to know module federation can also deal with version conflicts. It's one of the best features, if you ask me, about module federation. So the last question is how to use this with Angular. Well, if you go with Angular, you need a plugin. I've written such a plugin for you. You can just ng add it to your application. It generates a Webpack configuration. And besides this, under the hoods, it activates module federation within the Angular CLI. After adjusting the generated configuration, you can start your application and you should have a fully flagged micro frontend architecture. Just do this with your existing applications and you should be fine. If you use a different framework like React or Vue, then just use Webpack directly. Just use Webpack directly with the settings for module federation. On the other side, the Angular CLI is shielding Webpack from you. That's why here we need this plugin. Okay, now let's have a look at a demonstration for this. Let's see all of this in action. Well, what I've prepared here for you is a shell application capable of loading micro frontends on demand. When I'm clicking on flights, then the micro frontend shall be loaded here into the working area. By the way, the micro frontend itself has those red dashed lines. And as you see here, it runs on a different board. It runs on board 3000, while the shell runs on board 5000. This is not a prerequisite, don't get me wrong. You can totally deploy everything on the same server, but showing that I'm going with different boards really proves that I can deploy it independently. Well, you can imagine what happens when I'm clicking here. When I'm clicking here, we see that nothing works because this is now my job in this live coding demonstration. So let's add our plugin to the CLI and let's enable those two applications for module federation. For this, I'm switching to my console. Here I have already two tabs. One tab is for the Micro Frontend 1. The other tab is for the shell. First of all, let's get started with the Micro Frontend 1. And let me add my plugin. ng-add, plugin name. I'm using here the newest version. And I'm saying, yes, of course, I want to install this. And after installing everything, it asks me two questions. Namely, which application in your workspace do you want to enable for module federation? That's the first question. And the second question is, which board do you want to use? Well, in my case, of course, I want to enable the shell for module federation, and I want to go, let's say, with board 5000, as shown before. Oh, not the shell. Let's start with the micro frontend. And here it's board 3000. A lot of stuff is generated. First and foremost, this webpack config that allows me to configure module federation, but also some additional stuff is generated. For instance, some entries in your angular.js enabling you to tweak webpack underneath the covers in order to activate module federation. So let's do the same for the shell. I have another tab for the shell. Everything is downloaded. Yes, I really want to execute it. And then also I will apply a board and I will mention the name of my project. The name is shell, of course. And here the board is 5000. The same thing happens. Some files are generated. The angular.js is updated in order to register the logic for enabling module federation. If we look into the source code now, we see a traditional Angular application. There is nothing special in here. It is a traditional Angular application, or to say the least, a workspace with two applications, namely with the shell and the micro frontend. And one more time, having this structure is not the prerequisite. Here I'm having everything in one folder structure. You can totally have different folder structures. Especially if different teams work on this, it is beneficial to have different repositories. For the sake of simplicity, for the sake of demonstration, I'm going here with one repo, with one mono repo. Well, let's get started one more time with the micro frontend. If we look in here, we see it is a traditional Angular application. Everything is as we are used to it, everything. And then there is this webpack config that has been generated. You don't need to worry. This is not a fully flagged webpack configuration. It is just a partial one. A partial one just containing what you need for module federation. And this is first and foremost this module federation plugin here. This plugin comes with two blocks. We can use both of them, but normally we only need one of those commanded out blocks. The first block is for the micro frontend. The second block is for the shell. Well, you remember, here we are talking about the micro frontend, hence we are going with the first block. Let's uncomment the first block and let's remove the second one. So here I can assign a name to my micro frontend. I'm just fine with MFE1. This is the project name by default. I can define the name of a so-called remote entry point. You remember, this is the file with your metadata. The metadata the shell needs in order to know how to interact with this micro frontend. And here I can expose files. Let's expose a module under the name flights.module. And one more time, this is an ordinary Angular module now exposed for the shell under this pretty name. If we look into the module file, as you see here, as you know it has not much, but it has some child routes. That means after loading it, we can immediately jump to those child routes here. Besides this, I'm defining what I want to share. I want to share Angular core and other Angular libraries, and those options define how to deal with version conflicts. There are several options, as mentioned before. Singleton means only loads the highest version. So if there is Angular 10 and Angular 11, only the highest version is loaded. And if different major versions would be needed, because of strict version, we get a runtime exception. Fail fast is here the division. That means that hopefully we find out that we have a version conflicts regarding major versions, because having Angular 11 and Angular 10 loaded side by side in your browser might not be the best idea. This is just one option, but the option I prefer for Angular. You could say, well, let's just load the highest version. If you want to have version 10 and version 11, Singleton alone would just load version 11. Here we get the runtime exception. Hopefully some kind of integration tests find out that we are doing something in a wrong way. Okay, cool. This is my micro frontend. Everything as usual, everything plus those settings here in this webpack config. The same is the case for our shell. Also, the shell is a traditional Angular application plus this webpack config here. And here I can say, hey, let's get rid of the first section, because the first section is about the remote. Here I want to go with the second section, which is for the shell. And for the shell, I'm mapping a path. This path is called MFA1, which stands for Micro Frontend 1. And it points over there to another separately compiled, separately deployed micro frontend. It's also called MFE1 over there. And this is where we find the metadata. After loading the metadata, we have everything to interact with this remote to load this very micro frontend. Of course, this is hard-coded. This is what I'm calling static federation. You need to know that this webpack configuration is only evaluated at compile time. That's why this is hard-coded. But there is an alternative for production. For production, you will very likely go with the alternative that's called dynamic federation. We will have a look into it in some seconds. Okay, for the time being, let's stick with static federation. You have already seen it in this configuration file. I also defined that the shell is sharing those libraries we've seen before. And of course, now we need some root, some lazy root that is loading this micro frontend. For this, let me switch into my routing configuration, app routes.ts. Here we see that I have already prepared this lazy route, and it's doing traditional lazy loading, doesn't it? We have load children. We use a dynamic import to point over to our micro frontend. And this gives us an Angular module we want to invoke. This is fine for Angular, because for Angular, this is just lazy loading. This is fine for Webpack, because for Webpack, we have configured everything. Webpack knows about the mapped paths. This is not fine for TypeScript. You see it here. TypeScript is saying, hey, I don't know this file. I don't know this path. I'm about static typing, so I cannot guarantee that this will work at runtime. And so we need to tell TypeScript, it's okay, trust us, we are experts, this will work at runtime. Don't worry about it. In order to do this, we need a DDS file. The name does not matter, call it with the ending DTS, and it will be picked up by TypeScript. And here you can say, hey, we have this declaration for you. This will work at runtime. There will be a resolvable path MFE1 module. And so it's also fine for Webpack, no, for TypeScript itself. Awesome. So at the end of the day, traditional Angular applications plus a Webpack config, plus, of course, lazy loading. Now, I would say, let's try it out. Let's see if this really works in production. For this, let's ng serve the shell. Let's ng serve the micro frontend. This will take some time, 1 or 2 minutes. And after that, we should have everything up and running. Yeah, we had a luck because we started to compile the same libraries at the same time. So just restart this here. It's not a big deal. Angular is doing this for Ivy, compiling everything. And as it looks like there is an issue, let me look it up in my micro frontend configuration. Source, yeah, I missed the app. I think I should really install some plugin that gives me IntelliSense for file paths. Okay, let's start it. Meanwhile, the shell is started, everything is green, you know, that means we can already sell it. And here it also slowly starts up. And here we have the micro frontend one. And now we can try it out. Let's reload this. Let's click on flights. And hey, we see that the micro frontend is directly loaded in our shell application. It is loaded at runtime without knowing it at compile time. Let's have a look at the network tab for this. If we look at the network tab for this, we see this really looks like lazy loading at first sight. When I'm clicking here, yeah, it's loaded on demand. So it's really like lazy loading at first sight. But at second sight, it's a bit more because I'm loading something that was not known at compile time. To prove this, here I'm going with localhost 3000. Here I'm going with localhost 5000 as mentioned. And also, if you look here at the bundle size, you see this is really beautiful because this just has about 10 Ks. If you ask me, this really proves that here we are sharing Angular. Because if this micro frontend came with its own Angular version, the bundle size would be far bigger. And so we see we've solved the biggest issues my customers told me. We don't need a meter framework. We just can load everything with a dynamic import, and we can share libraries. This is also quite easy, and so we can decrease the overall bundle sizes. Well, just let me show you a remaining tiny thing, namely, let me show you how to go dynamic with federation. Because, you know, so far in the configuration of our shell, we needed to define the location of the micro frontend in a hard-coded way. And this is kind of nice for testing and for prototyping. It is not nice for production, because when it comes to production, we don't want to know about all of this upfront. We want to get informed at runtime about the location of the micro frontends and about the available micro frontends. For instance, we could call a lookup service telling us, hey, this micro frontend is now available here, and there is a new micro frontend available there. So let's go dynamic. Let's comment this out. Let's move over to my routing configuration, app routes. And here we can switch out the dynamic import by a helper function. The helper function is called load remote module. Load remote module gets up to 3 points of information. For instance, we can define the remote entry, which is the file holding all the metadata. It was this file here. Then we can define the remote name, which is MFE1. And then we can define the exposed module, which is /module. You see, here we are defining everything using strings at runtime. We have defined before, either in the Webpack configuration or within our import statement. And because we have just strings here, we can load those strings from some service. We can get it dynamically. For instance, I could put the string into a variable or a constant URL, which comes from the backend. It's not a big deal. Okay. In order to try this out, we need to restart the shell because we have just changed the configuration. It should not be that a big deal. And immediately after 3 hours or something like this, we get the shell. And now when I'm clicking here, everything is loaded dynamically. No, nothing is loaded dynamically. I don't have that much luck today, as it looks like. Yeah, my fault. I need to tell which Angular module to use. But now we are on the safe side. Now it's loaded in a dynamic way. Let's have a look to the network tab. Let's click here and let's click on flight. Now we need to reload. And yeah, you see everything is loaded now at runtime, even the metadata, the remote entry file alongside my bundle. And don't be scared away of the bundle sizes. The remote entry is really huge in debug mode, but as promised, in production mode, this file has only 2Ks. Here it has about 30Ks. There is some additional theory about loading this metadata at the right point in time, but you can find those theory if you are interested in the README of this plugin and also in my blog. Awesome, isn't it? We are capable now of loading separately compiled code. How cool is that? So let me come to a conclusion. We have seen micro frontends are not a free lunch. They come with consequences, as almost everything in this terrible world here. They come with consequences. That means you need to decide if they fit your needs or if they are an overkill for you. It is first and foremost about scaling your teams. That means you have to have more than one team. And it's about distributing your business domains among your teams. And you have seen that module federation is really a straightforward way for dealing with micro frontends. It solves the biggest issues my customers had. Namely, you don't need a meta framework. You can just load your micro frontend using a dynamic import, using lazy loading, and it allows you to share code in order to minimize your bundle sizes. Really beautiful, if you ask me. And there is one last thing I really want you to remember, namely, please always remember my story with the moped and the scooter. Because this story really shows there is not the one and only perfect solution in general. It always depends on your very situation. Each and every option has advantages and disadvantages for your very situation. That means you need to evaluate. Keep this in mind. Okay, thanks for having me. Here you'll find my contact data. I have already uploaded my slides and my examples to my blog. And if you like, follow me on Twitter to stay in contact. Thank you and have a nice day.